everybody in YouTube land, and welcome to this episode of From the Mind of an Appliance Technician. My name is Chris. Thank you guys so much for being here. This is C&G Appliance Television. Without further ado, let's get right into this because I've got a lot to talk about. First off, shop announcements. We are looking at the 11th of February already. It's started out to be a pretty busy month, so that's why I have kind of shorted you guys on the uploads, but I've been getting my sealed system game on for the shop. I just did a Sub-Zero TR or 700 TR2 evaporator change. That seemed to go just fine. Just a little side note on those things: they have an update on the evaporators. So when you actually do them, they include a little side panel with the switches in it and everything. And you actually that actually compensates for the change of where the lines go. So you've got to keep that in consideration. I kind of had to learn that the hard way, and I kind of had to shove the line set down a little bit. If it were up to me, I probably would have shortened the existing line set by probably about I probably would have lopped about an inch off of them to get it to where I needed to be without too much of a fight. So just something to bear in mind. Shop announcements for restoration and flipping. Pretty much we're still I finally got around to putting that clutch and that speed queen washer. That goes back together tomorrow. I've got a buyer for that thing. I've got another direct drive machine. Actually, I have fixed one up for one of the coworkers, for one of my wife's coworkers. So that was cool. I may even play with a beverage air commercial refrigerator. I don't know what the deal is. It just kind of appeared in the pen. And I'm kind of thinking I might, if I can find a part source for it, I think it'd be kind of cool to play around with, just because it's something different. I'll take you guys along with me as usual. Side note on the Speed Queen washing machine that I'm talking about, the one that I put the brake assembly in, not a clutch, excuse me, it's actually a brake. It looks like a clutch on a car, that's why I kind of refer to it as such, but it's actually a brake assembly. I was putting that on, and I kind of did a little bit of a feature on how to remove those springs that suspend the tub downwards. The tub kind of rides on a disc, or the whole tub assembly kind of rides on a disc, and it's suspended all the way around by a set of suspension springs. So I touched on a little novel way to disconnect those springs, so make sure you guys go and check that out. It's in my previous videos that I've already uploaded, so make sure to go and check that out, guys. Okay, so on to my topic. It kind of relates to that 700 TR2 that I was talking about, the Sub-Zero. Guys, I want to stress the importance today of being a full-line technician. Knowing your sealed system stuff is a great way to start, because everything else, as long as you have electronics troubleshooting down, as long as you have basic theory of like washers, dryers, and how to troubleshoot those things, dishwashers, things like that, and as long as you have the basics down for refrigerators, i.e. how to deal with a defrost issue, how to diagnose refrigerator problems. Once you get to that point, let's say you have a compressor that's out, once you get to that point, I think is a good it's a good skill to have in case you need to replace a compressor. Really, the company I work for services what we sell, so a lot of times I'm in a position to where I don't do as much sealed system work as other technicians in my field. There's guys that do sealed system work all day long. The guys that are owning their own business, that are out there killing it with warranty companies and things like that, they are more likely to pay for that repair because it's cheaper than a new fridge. And that's all the warranty companies, all they care about is the bottom line when it boils down to it. Go check those guys out. Mike Miner at Up and Running Appliance. Go check his channel out. Go check TMM Appliance out. Go check out Mike Check and my buddy Mario over at Polair Repair. Go check those guys all out. And anybody else I forgot to mention, I'm sorry, but yeah, go check those guys out. They've got a lot of information too. And I want to stress the importance of being a full line technician. That means being able to work on anything that's put in front of you guys. Sealed, like, compressor work. What do you need to get started in sealed system work? Well, you're going to need a vacuum pump. You're going to need torches, oxyacetylene rig. Some guys use lock rings. I would become familiar with those as well. That's a little bit different of a kettle of fish. Again, go check out Brandon at TMM. He's got a whole workshop that he does on those lock rings. It's really good information. Guys, don't just take my opinion for appliance repair. I want you guys to be checking. Like, if you are looking on YouTube for appliance repair, I want you to check everybody out in the field. Taylor Cousins, TC Appliance Repair. That's another dude that I want to give a shout out to as well. He's inspired a lot of the guys that I talk to, and myself as well. He's got a lot of how to start out in the business, and like if you're starting your own business, don't just take what I do, but take information from a whole bunch of different sources, guys. That's the best advice I can give you in that realm. So let's recap what you need to at least get started in sealed system repair. You are going to need a recovery machine. Okay, you're going to need a recovery bottle, because that's the first step, is you recover the refrigerant. Okay, because this stuff, you got to remember, refrigerant is a pollutant. It can't get released into the atmosphere. Okay, so you are going to have to pull that system down, recover it into a vacuum, and dispose of it in a container, which is usually in the form of a gray and yellow bottle, I believe is the code for a used refrigerant bottle. And mine is a mix. I've got 410 in mine. I've got R134 in mine, because sometimes I'll have to service window units as well. So it can accept anything, basically. And I think there's even some R22 in there, really. So yeah. Anyway, so you're going to need a recovery bottle, recovery machine. You're going to need a vacuum pump. That is vital, guys. That is absolutely vital, is a vacuum pump, because that's going to prove whether or not you have leaks in the joints you just made. Speaking of joints you make, you're going to need to have a torch rig, which is oxygen and acetylene bottles. Okay, those two things come together and they make brazing possible. Okay, you're going to need solder. Lots of guys use lots of different solder. Okay, I use 45% nickel, I believe is what I use, but I also use 5%. I use the kind with the flux around it that's like $15 a stick. I'll use that for joining dissimilar metals, because you also need flux, because you need flux to join two dissimilar metals like copper and aluminum, okay, or copper and steel. You need to become familiar with the brazing process, okay? That is absolutely vital to sealed system. You need, let's see what else. You need gauges. You need gauges that will handle R134. Eventually, we're going to be transitioning to 600A in the industry. Probably, I would predict within the next 10 years, you're going to see a lot more units in 600A. Okay, and we're going to have to become familiar with servicing those units. I've had a little bit of experience with 600A. I have done one machine, and that was a small little under-counter U-line deal that I just happened to do in the shop, because some guy just was trying to defrost his evaporator with an ice pick and poked it right through it. So those are pretty much the basic things you need to start. There's other things that you could throw in there, like a Swage tool. A Swage tool is really great. Now, a Swage tool, I don't have an example of one with me, but it has like little steps on it that will actually interface with different size pipes and will actually flare it out so you can fit the same diameter pipe into it. Because, again, when you're brazing, the less connections you make, or the less brazed joints that you have, the less chance of a leak that you are going to have. Okay, so there's all that stuff that comes into play. And again, don't just take my word for all that stuff, guys. Go see what everybody else is using. Okay, that's just the basics to get you started. Okay, you are probably going to need a whole bunch. You might need a whole bunch more than that, but that is just the basic guidelines. Okay, so I hope that with that, I hope that helps some of you guys out there. And the importance of being a full line tech, guys, is invaluable. Okay, I know some companies that you might start out for will kind of sandbag you and have you specialize in like washers, dryers, cooking products, things like that, and they'll just keep feeding you that work. If they determine that you're good at something, they're just going to keep feeding you that kind of work. Like the big companies like Sears. I don't know how Mr. Appliance works, but Mr. Appliance, if that's in your area. But again, those are some of the best places to start. Okay. Now I work for a company, but I'm their only tech, so it's kind of like I run my own show most of the time. There's a few responsibilities that I don't have to worry about, like the business administration side of things, running a business right now. Those are things that I'm not responsible for. So I can focus on being the best technician that I can, which is something that I really enjoy, because I rather enjoy the technical end of things. Okay, and I think that's kind of the mindset you have to have when you are coming into appliance repair. You've got to have you've got to have that sort of analytical mind. Okay, you have to, and you'll get a feel for what causes what things to fail, if that makes any sense. What causes what problems? You'll get a handle on that. And guys, sealed system work, there is a heck of a learning curve with it. Now, before I was in appliance repair, I was doing heat and air work, and that will get you a basis for appliance work, but you have to play around with even different things in the appliance world. Dialing in refrigerators. Ice machines are going to behave differently than refrigerators a lot of times. But it's the same principles at play. Okay, I find dialing ice makers in, or ice machines I should say, standalone ice machines, dialing them in as far as refrigerant charge is a little bit of a pain. And there's a learning curve to all that stuff, guys. And it's just something you're going to have to learn as you go. So that's why I advocate getting started for a company first, and not right away going out on your own. Get at least 5 years with an existing company before you step on to your own, because that's going to give you some real world experience, and it's also going to build your confidence in an environment where you can just focus on being a tech. That would really be my best advice in that respect. But if you are a full line tech, there isn't a place in the world that you cannot go. You can do anything. Sealed system is the biggest learning curve, I would say, to all of it. The next in line would probably be electrical troubleshooting. There's a lot of gremlins sometimes you can chase. Like today, I found a French door Whirlpool refrigerator, just basically your standard one. Your standard, it was a WRF 736, I believe. Don't quote me on that, but it was similar to the WRF 736. Similar interface, same board, everything like that. It's the board actually that I did a video on a while back. It's the same configuration of that. It was just black. So I went immediately, because when you, as the Appliance Samurai says, it's all about being able to troubleshoot something with minimal disassembly. Okay, you want to get to things to figure out the problem quickly so that you can, like, if you have to disassemble something, then go for it. But we have to determine whether we have to disassemble something in the first place. Okay, so my first target was the board. I set it into force defrost mode in diagnostic. In the diagnostic menu, there is a test 6 that you can set the thing into defrost mode. So I go back to my power at my board that is on pin or connector P2, and it's, I think, the red wire coming off of P2, but don't quote me on that. And then you just pick up neutral somewhere, and if you're getting power out of the board, okay, the board is trying to power your heating element. Well, next thing I do is I open it up. Of course, first thing was I see rime ice in there. Lady's original complaint was the ice maker wasn't producing ice. Check temperatures. First thing, what's the first thing you do when you get there? You check temperatures. Okay, that's the simplest thing that you can do that will indicate a bigger problem, yes, but that is the simplest thing that you can do. So regardless, if you think you have a refrigeration problem of some sort, when you're going in there, they say, okay, my ice maker's not producing and my freezer isn't getting cold enough. First thing you think, oh crap, I've got a sealed system issue. So take my temperature gun and I'm checking temperatures in my ice box. I got 30 degrees in my ice box up in the ceiling of the refrigerator, and then I close those doors and I go down, open the freezer, see a bunch of rime ice. I'm reading like 18, 20 degrees. And when you stick it in some product, now guys, make sure that you stick your temperature gun or probe into some product. Okay, that is the best way and most accurate way that you are going to get the temperature of that freezer. So I shuffle around some product and I stick my temperature gun underneath it. I'm reading like 18, 20 degrees in there. So, and then I look at the back wall and then I see there's rime ice, which is that sort of snow ice. That's actually the term for it, all over the back wall. Okay, so then I go from there. I say, okay, I check my door seal, which is right in front of me anyway. No rips, no tears, no nothing like that. So first place I go from there is the board, okay, because I don't want to have to pull that whole back off or anything like that. I don't want to have to pull the door off and all that crap. Ended up having to anyway because I saw, like I said, I saw power at the board, okay, so I put the board back together, pull the door off, pull the top shelf out, pull the panel off on the back, okay, after I had defrosted everything to the point where I could test the element and the bimetal if necessary. Now, you don't always have to test the bimetal. Most of the time you can assume that the bimetal is good if the top of it isn't pushed out, because a lot of times moisture will get past that top seal in the bimetal thermostats and push that top out. That's really the only way that I've ever seen a bimetal be bad. But if you really want to get technical, you can clip that bimetal out of there and stick it in a cup of ice water. And then you look on the bimetal itself and it will tell you, or it will tell you in the service information, whichever you have. If you do not have the service information, it will usually tell you on the bimetal thermostat itself what temperature it opens and what temperature it closes at. So you want to make sure that it's open or closed if you're in that forced defrost mode and you're trying to test the element. But next thing I do, pull my element connectors. I pull the white connector off of the side. The back of it comes right out the connector. So guess what? I just found the problem right there. It wasn't connected all the way, therefore it wasn't transferring all of its power through the heating element. So all I did was I bent that tab back out, stuck it in the back of the Molex connector, connected everything back up, put it back in a forced defrost mode after defrosting the fridge, of course, and then voila, defrost heat. So guys, that's the diagnostic process that I'm talking about. That is what you have to get into the mentality of. So before I go to a call, always, what am I doing? I'm rolling things around in my head. I say, okay, well, it could be this, 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 or this. I need to start with the simplest thing first. And that is always what you do in a diagnostic process for anything, okay? But if that problem had materialized and I had been reading like let's say a 40-degree freezer and everything was thawed and the lady's panicking or whatever, I'm going to go to my compressor. I'm going to see if my compressor is running. I'm going to see if my condenser fan is running as well. I'm going to have to see a lot of different things. I'm going to have to see those different things. If the compressor isn't running, should I try a 3-in-1? Okay, if the compressor is running and the fans are all running, well, then you might have a leak somewhere, and we have to know the process to diagnose leaks. Now, again, I use dye for leaks. I have a special dye that I shoot into the system. It's the same stuff that if you were to replace a filter dryer when you do a compressor, which you always should be doing. You guys hearing me out there who do sealed systems? Change your dryer if you change a compressor, because they puke all through the system. Okay, when bearings go bad in a compressor, they puke through the entire system. And guess what takes the brunt of all that barf that it spits out? Yes, you guessed it, the dryer. So when I introduce a dryer into it, I'm going to introduce a dryer with dye in it in case I have leaks down the road. Okay, if I have to come back, I already know, okay, hey, I put a sticker on it that says this unit has a dye dryer. So that way when I come back, I open the door, and right by the model number, I have a little reminder that says, hey, ding dong, I put a dye dryer in this. You ought to be looking for leaks at the dye. You can look for leaks right now. You don't have to shoot a dye charge in it, okay? And that saves time, okay, in diagnosing compressors. So I know this was a lot of rambling information, and I'm just kind of saying this as it comes to my ADD brain. That's why this is the mind of an appliance technician, guys. That's my ADD brain. So I hope you guys can keep up with that. We're after the 20-minute mark right now, so I really appreciate you guys for being here. And that's just kind of a quick rundown of one of the things that I do in the diagnostic process that I go through to find the root cause of a problem. Okay. Additionally, I'm also going to add towards the end of that, if I hadn't found that connector, my next step would have been to ohm that heating element. Now, defrost elements typically ohm out. Now, you're not going to want to test continuity because your meter won't show continuity all the time on any elements, okay? You want to be testing for ohms, okay? Your bake elements are typically around 30-something, 40 ohms. Your defrost elements and your dishwasher heating elements as well are going to be somewhere in the neighborhood of like 30 to 50 ohms, somewhere in there. Those wouldn't be an astronomical reading to me. So just a bunch of quick information, a bunch of quick tips that I threw at you guys. I hope this helps some of you guys. I hope this helps some of you guys become confident in starting out sealed system work. And as usual, if you guys have any questions, put them down in the bleep bloops down below, and I will definitely check them. I respond to every comment. Not that I get too many comments on these videos, but I try to respond to every comments or all comments that I get. So, please comment with any questions that you have. I'll be happy to answer those for you guys. With that, I'm going to end this episode here. Thank you for bearing with my ADD rambling, and I will catch you guys on the next episode.